Hello everyone, myself Orgodeep and welcome to my screencast of the weekly contest 360. We are already late by about 1 minute, so let's start without wasting further time. You are given a string moves of length and consistent characters ALR, and this string represents your movement or number line starting from the origin 0. In the ith move, you can choose one of the following directions. To the left, if move psi equals to L or move psi equals to OK. The furthest point you can get to after n moves. Okay, I think like we have to maximize the number of L's or the number of R's, right? Got it. So here int left equal to 0, right equal to 0, extra equal to 0 for auto, and move in moves, auto and move in moves. If move equal to L left plus plus, else if move equal to R right plus plus, else extra plus plus. Now return max of right comma left plus minus mean of right comma left plus extra. I think that this should work. Three five seven, this thing should work, and it works. Cool. Next problem. What is the minimum possible sum of a beautiful array? You are given positive integers n and target. An array nums is beautiful if it meets the following conditions. Num.length equal to n. Cool. Nums consists of pairwise distinct positive integers. Cool. That does, I think I am recording right. Yep. Num consists of pair of distinct positive integers that there doesn't exist two distinct indices ing in the range 0 to n minus 1, such that nums I plus nums j equal to target. I think I have seen this problem earlier. I think in the previous contest actually. Pairwise distinct positive integer. Yep. So just I have to do the same thing. Like I can start from 1. Then I cannot include 2 since it is already included. I think I've got the. Just first we will explain in the afterwards after contest. Now we are running out of time. Let answer equal to 0. You can just take a map. No. Target is up to 10 raised to the power 5. So anything above 10 raised to the power 5 can be included, right? So 2 into 10 raised to the power 5 integers up max can be taken, so it's fine. I think map of ll comma cool used while m. Okay, ll current equal to 1 if not of if not of used target minus current used of current equal to 1 in minus answer plus equal to current. I think this thing is the thing that should work, but I make a time limit exceed, I think. Okay, comparison error int target. Acha, I think this should work. 2 3 1. Okay, no, it's not working. Okay, if not of else it should be current plus plus, right? 2 3 1 again. Cout n first case it's 2 3, right? N equal to 2, current equal to 1, answer equal to 0. N equal to 1, cool, current equal to 1, answer equal to 1. N equal to 3, current equal to 1, answer equal to 0. Okay, how the hell of N is increasing? Okay, N equals to 1. Okay, got it. Three, 4, 2, right? No. When N equals to 1, current equal to 1, answer equal to 1, right? Then N equals to 0. Acha. Current plus equal to current, and in both cases it will current plus. Shit, what I'm doing here? Okay, yaar. N equal to 2, current equal to 1. Acha, let's take only one test case. 2 3 only. FB easy to debug. Time is running out. N equal to 2, current equal to 1, answer equal to 0. Cool. N equal to 1, current equal to 2. Acha. N equal to 1, current equal to 2. Acha, answer is here 4, right? How come the answer is coming out? Acha. Got it. Now it's right. Yep. So let's see something for this. 481. I think it's correct now. Cool. Let's now move to the third problem. Minimum operations to form subsequence with target sum. This looks like a hard problem. Okay, it's medium only. Minimum operations to form subsequences with target sum. You are given a zero indexed array nums consist of two non-negative powers of 2, okay, and an integer target. In one operation, you must apply the following changes to the array. Choose any element of the array numSi such that numSi is greater than 1. Cool. Remove numSi from the array. Add two constant numSi to the end of I. I've also seen this problem here somewhere in code for this all, but not sure, and I don't remember the approach. Add two occurrences of numSi by 2 to the end of nums. Return the minimum number of operations you need to perform so that nums contains a subsequence whose elements sum to target. Okay, so I need to get 7 here. Let's use my copy pen once. 7 means 111 in the binary form. So we have 1 to 8, right? Acha, so like we can do something like this. We can just move from the highest bit towards the lowest bit. So like 8 here. Yep. Okay. So like in this case, I just need to use one operation to get 8 to 4. I think we can just greedily perform that operation and that will be okay. Yep, I think that should be okay. So I'm not sure. Like in this case, the target is 12. So like 8 4 2 is what I require. Sorry, 8 and 4 is only what I require, right? So 8 can come from only from the 32 part, like, so one operation to 16, one operation to 8. So that gives me 2 operation. Yep. 1 1 16 8 8. Acha. Some required, right? So you can also merge elements. Got it. think let's check this problem once on the internet. Think it's an used problem. This one is not. 132 one. Yep. Okay. Okay, so let's check this one on internet with the tag code process. Okay, so not finding. Let's try yourself only. How many people solve this problem? Okay, 7 people. So it's not that much of easy. Is this people's problem solved by more people? No. Cool. Sums contain a subsequence whose elements sum up to target, right? Okay, so like this, what I was previously thinking, like the highest to lowest part, it's not gonna work. Acha. Okay, so let's see the constraints one. Okay, then nums has a pretty short length, so you can think some kind of a DP approach here. Up to 1000, like n square DP will work, right? So like target has value up to, no, target has also high value. Okay, so like if I have a value of, let's say 16, how much value can I extract from that? Like how much part am I willing to take from this part? From 16 I can take 8, I can take 16 whole, or I can take 8, right? I can take 16 whole, or I can take only 8. 16, yep, only 8, or from here I can take 8 plus 4, right? Let's just break 16 once. 16 can be broken into 8, like 4, 4, 4, 4, and then it is okay. So I can just break it into as many components and then try to find the subsequence. That is fine. No, that's not fine. 2 2 2 2 2 2 2 2, right? And then 1 1 1 1 1 1 1 1 1 1 1 1 2 3 4 5 6 7 8 9 10 11 16. Okay, so I can obtain any number from 16, right? Okay, so it is always optimal. So like in the case of 1 to 8, right, it is always optimal, since from 1 and 2 I cannot obtain 7. So I need to break 8. Okay, I think I am missing something here. No, I think these ones. I bet this is a previously used problem. But I'm not able to find it. Okay, not finding. Cool. Okay, so I can do something like this. Okay, since it's only powers of 2 only, so that gives us some good opportunity. Like the count of ones I can consider, count of 2s, count of 4s, count of 8s up till 30s, right? Yep. Let's move to the next problem. We can come here later. So next problem is also an easy problem. Yep. I'm sorry, but it's also a medium problem. You're given a zero indexed integer array receiver of length n and an integer k. Cool. There are n players having a unique ID in the range 0 to who will play a ball passing game, and the receiver I is the ID of the player who receives passes from the player with IDI. Acha. Players can pass to the player. Okay, cool. You must choose one of the n players as the starting player of the game, and the ball will pass exactly k times starting from the chosen player. For the chosen starting player having ID x, we define a function fx as the sum of x. Acha. In the IDs of all players who receive the ball during k passes, who got it. Starting player having ID x that maximizes the value. This seems like an interesting problem. These two problems are both interesting. This one I have seen somewhere but not sure. But this one is in I have not seen anywhere. Starting player having ID x that maximizes the value of fx. Return an integer denoting the maximum value of the function. Like receiver may contain duplicates. Cool. So I think it's a graph based problem. Like we can draw the graph like 0, like for the first case 2 0 1, 0 will pass to it will be a obviously a directed graph since not both ways. 0 will give a pass to 2, 1 will give a pass to 0, and 2 will give a pass to 1. So it becomes a cycle of it actually in this case, and k equal to 4. Pass number x plus receiver IDs. What is this? X plus receiver. What is x here? So it starts from the player 2. Cool. Pass number 1, sender ID 2, receiver ID 1. Okay, x plus receiver x value becomes okay 3. Cool. Now in the second case 1 gives to 0, the value remains same. The third case 0 gives to 2. Okay, so it becomes 5 again. In the fourth case 2 gives to 1, becomes 6, right? So it will maybe something like this. Cool. So it's like iterating in this cycle. K can be pretty huge. I have no idea about both these problems. Let's say the ranking ones, like how many people are actually solving. Okay, I have a pretty bad rank here. Third problem is solved for a lot of people, I think. Okay, no. It's actually I messed up in the first two problems. Got it, not by a lot of people. Cool, no problem, it happens, but I think this one is easier compared to this one. The fact that nums contain a subsequence, I think let's copy. I think I can get some ideas using this statement. I search for code, searching code forces. No, this is one is the not. something, not searching properly. Okay, let's think properly. I'm not thinking hard enough. Cool. Not solved by a lot of people, so I can think with a fresh mind. So it's not an easy problem, right? It is in the minimum number of operations so that numbers contain subsequent whose elements sum of target. Okay, let's think properly. Okay. Sure. N is up to 1000, right? Okay, so one condition, like it's the sum of all the elements, so the sum remains the same, right? The sum remains the same. What I need to do is discard some of the elements, right? Discard some of the, so if the sum is less than target, then in that case we have no option, but the answer should be simply -1. But if the sum is greater than target, then I think there is always an answer, right? Yep, sum is greater than target, then answer is always yes. Sum is greater than equal to if it is greater than equal to target, right? So we can just add this check here first. Let's just do some pre-computation so that we don't have to care about. Okay, first let's think about the whole approach, then do the coding, but it is easy. So now if it is sum is equal to target, then obviously the answer is 0. We don't have to do any operation. Now if the sum is greater than target, what we need to do is that we need to find we need to remove some elements with a cost of sum minus with the summation value of sum minus the target value, so that the remaining part becomes and I have to perform some operations here, because if the value is sum, then every value from 1 to sum can be achieved, right? Cool. Okay. Cool. Okay, so like let's take some cases and try to figure out. For the case of 1 to 8, right? If the target is 1, answer is 0. If the target is 2, answer is 0. If the target is 3, answer is 0. The target is a pretty huge value here. We cannot do DP, like there's some other DP stuff I have to think of. If the target is 3, answer is 0. If the target is 4, now in this case we have to perform one operation. If answer is 1, right? Now if the target is 5, then in that case, okay, 5 can be already obtained from 4 and 1. Let's not do that. 1 2 4 4, right? So 5, answer is 1. If the target is 6, answer is 1. If the target is 7, answer is also 1. Cool. The target is 8, answer is 0 again. Cool. If the answer is, if the target is 9, okay. If the target is 9, answer will be 0. Since the target is 10, answer will be 0. The target is 11, answer will be 0, and that's the end. Something like this will be happening here, right? Sure. Nothing some ideas actually. One 2 32. In this case, 1 is 0 0, 2 is 0, 3 is 0, 4 is also 0, right? So 5 is not 0. 5 is very difficult. 16 16 18 16. 5 will be 3 operations. 5 3 operations. 6 will be 6 will also be 3 operations. 7 will also be 3 operations. 8 will also be 8 will be 2 operation, right? In this case is 8, right? Okay. 9 will be 2 operation. 10 will be 2 operation. 11 will be 1 operation, sorry, 2 operation. 12 will be 2 operation. think can do some kind of a greedy approach here. Don't know. Okay, so like initially let's say we want a target of 12, right? Yep, right. Let's say we want a target of 12, so 8 plus 4 gives 12, right? So can we obtain 4 from this? Okay, I don't have any idea. Maybe this one will be a little bit easier. So let's try this one only. We'll be given some graph with nodes, right? And it will be a directed graph, and we have to find, okay, this problem can be done using LCA, something like this. Okay, 10 raised to the power 10. Yep, this problem can be solved using LCA, I think. Yep, lowest common ancestor, using that thing we can solve this problem, right? Duplicate times. Yep. I think this is doable using that. Like how it can be doable is that we can just choose iterate over all the starting players. Yep. And okay, don't just iterate over it. Yep, and just iterate over it, and then go as much as we can. Okay, and it will always be some points. Okay, so like 10 raised to the power 10 means, okay, I think we can do the LCA technique. Okay, I think I have the code for LCA here. Okay, LCA. Okay, I have to make it first C++ file. Test.cpp. LCA. Cool, right? Okay. Command C. Command V. Next, I don't know what is height is this part. Cool. Cool. So, okay. The IDs will be from 0 to okay, n, right? Can just resize all of this. Can just resize all of this in the function, what it will be called. Right. Okay, so this one is done, and after that what we do here is that we just do this here in the function, right? Got it. Cool. Like vector of g ll g of, okay, ll n equal to receiver dot size time. We have time left now. We can still solve all the problems. Of ll g of n, right? G, okay, time being here. G dot clear lca dot clear height dot clear think 40, 50, 50 will be okay, right? 2 is to the 50. 2 is to the 50 is 1.1 to 15. Cool. 50, I think 50 or 40 will also be okay. Right. CP. See out. Acha, I'm gonna compile here. Sorry. If 50 or 40, we can just okay, something like this. 30 will not be okay, since 10 is to the 10 is there. 40 will be okay, I think. 40, just do 40 and escape the other part. Come on. Like, we will look into this part, like how to do these things later part. Now for height dot resize n. Now for l I equal to 0, I less than n, comma I plus plus g of I dot push back ci receiver of I. Push back, let's do push back also. Arey yaar. Cool. Now what to do is that we to do a DFS. Let's choose the starting node as 0 only, parent, and now is the current height. Right, so just do a DFS call here so that height gets set, LCL node gets set. Right, now comes the important part, like okay, we have to accent some height starting from every node, right? So for every node I need to store like how much it can go, like how much it can like the cost. Okay, like the got it like something like this. Okay, let's check Sublime Text Board fonts. LCA, I think this one is what I need to do, something like this. I'm not sure how to do it here. So here lift will be 40. Okay, so LCA part not zero. Okay, and I can have to make LCA cost, right? So LCA will store the parent and LCA cost will store the cost from that node up till that height of parent. Now things making sense. LCA cost of node 0 equal to node, right? Okay, LCA dot clear LCA cost dot resize n, comma rel 40, and this would be -1, and LCA cost dot clear GLCA hide LCA or GLCA hide LCA cost, right? Now these things. Node equal to 0, node less than n, comma plus plus node. This is the initialization part. X equal to LCA node lift -1. Cool. Okay. Set node lift -1 if LL. Okay, and this can also be set to -1, right? LCA of node lift equals to LCA of x. Okay. LCA of node lift equal to LCA of cool. LCA cost of node lift equal to LCA cost of node lift -1 plus LCA cost. If LCA of x lift minus 1 not equal to minus 1. So here is a check we need to perform here. First is equal to plus LCA cost of x lift minus 1, right? I think this summarizes the whole thing. Now for LL node equal to 0, node less than n comma node plus plus, this is the start node basically. LL current node, okay, plus LL current node equal to current node equal to node, right? And we can do keep an answer variable just so that lastly it will return answer. Current node equal to node while, okay, like for LL bit equal to 0, bit less than 40. 2 is 40, 30 into 10, right? Yep. So 40 will be fine. At plus plus if k and LCA of node bit and LCA of current node bit. K, I think value of k is greater than 1, right? Greater than 0, right? Achha. Not current answer equal to 0. Current answer plus equal to LCA cost of current, LCA cost of current node bit, current node equal to LCA of current node bit, right? Answer equal to max of answer comma current answer. Time is running out. Let's just on some example test cases. 201 form. Let's check for the first one only first. Achha. Runtime error. Okay, this is not cool. Okay, like where is the runtime error occurring? I think in this part only. So just comment this so I can check it out. I think not, but no, in the other part. Okay. Is in this part? I don't know. Achha, so this part is okay. This part is not okay, right? Okay, in here in this part something is bad is happening. Sure. No, so I'm doing something wrong here actually, right? Okay. 0 means up till the first parent. 1 means, okay, 0 means like close to 0, so the first parent. 1 means second parent, like this 0. Got it. So I'm doing something wrong here. What I'm doing wrong here? 201. Okay. I can do something like this only, like without doing this shit. I think this is something doing wrong here. gf variable specify for I. अच्छा, receiver may contain duplicates, right? Okay, so like this thing will then not be applicable. Come on Z, come on Z, come on Z, come on Z. DFS child node now plus 1 2 if node if PA not equal to -1 LC of node. अच्छा, got it. I think I've got it here. Okay, like okay. So every node has got one polygon, so I can just avoid this thing. Got it. I can just avoid this thing. Okay. LCA of I0 equal to I plus receiver of I, right? LCA of I0 equal to receiver of I. LCA cost of I0 equal to I plus receiver of I. I think it's a DFS part actually. So take up compilation receiver of I. I'm taking a lot of time to code this up. It's not good. 0, right? So I think this part is also okay now. The final part answer is 0, so you have to look into that. That is fine. 2 0 answers belong to is 6, right? I plus receiver of I, right? Because let's start from the node 2. See out क्या bit equal to bit current node equal to current node, answer equal to LCA cost of current node bit. अच्छा, so like we don't include this one, right? Fucking up here. So that we want to move from this node to this node, right? From the 1 2 3 4, right? The first one will contain this one, then will contain this to sum, contain these to sum, right? Third one will contain this sum. ABC plus B plus C. वो तो मैं कर सकता -6 or something like that 15 है. अच्छा, okay, so it's not running here actually. What's happening, bro? It's 4, right? If not equal to 2, अच्छा, and what will it be? Okay, shit, what I have done here. I'm really out of practice. That's it shows this. 6 is the answer, right? It's the correct answer, but I'm to be sure that it's fine because I need to do some cases here. Okay, LC of node left is LC cost, is LC cost of node left, LC minus x. Cool. I think this is cool. 613, right? Okay, it's not giving the right answer. Starting ID is 4, right? So for 4 and less than equal to 4. 4, okay. Okay, shit. Let's see. 13, right? I think do not need to include this. Don't know. 2 and ठीक है. That's right. So like we are initially here, like from this part, not this part. This might work. I think this is what I'm missing here. I think so, not sure though. Cool. We are having a bad contest. Can't do anything. Bait equal to bait, node equal to node. 2014 नहीं. 1233 अच्छा. Bait equal to 0, node equal to 4. अच्छा, it's not in this node part. Bait equal to 0. अच्छा, 3, right? Okay, let's draw this graph once. Let's not draw. The 4 I have started, right? So from 4, okay, node equal to 4, current equal to 3. Current meets current node, right? अच्छा. 4 cost equal to current answer, right? Cost 7, right? From 4, right? From 4th node, okay. 0, 1, 2, 3. Bait is 0, so from 4th node, okay. So how is it bait 0? Okay, from bait 0, from 4 to 3. 0 1 2 3 4. Okay, so 4 to 3, the cost is 7, right? That's okay, cool. Okay, then from 7 maximum we have to do, right? From 7 bit 1. Okay, cool. Bit 1, hmm, 7 bit 1 node equal to 4, current equal to current equal to 1. Okay, from 4 3 we need to go to minus x, right? Okay, this solves the problem, though I'm not sure. Okay, runtime. Okay, sorry. This was 610. Okay, solves the problem apparently, but I think this is the correct solution, right? This is the right solution. 610, right? 610. But if we get wrong answer, we will dive deeper into what's happening. Cool. No, I don't get wrong answer. Accepted. Now for the final problem. 600 people have solved this problem, so it's an easy problem, I think. But not easy, but doable for me problem. I have no idea how this works. Sure. Seek my rank once. It should be around 700, 800. Yep. 900. People solved it in 3 minutes. Wow. Hmm. 4 minutes. Indian guy. 10 minutes and all. Yeah. I'm missing something here. This is not DP and something like that. This one doesn't have something similar. I've seen this problem here, similar problem somewhere else. Let's think only. Don't have any other options. If we have about 9-7, 20 minutes time left. 10 minutes recording. Impossible. Let's write what we have achieved till now. Right. It will not get out of time, like out of 30. I don't know. Let's do long. Be safe. Let's just code up whatever we have. Let's do and submit that. Less than target -1 equal to target 0. These are the base case actually. I think just this title with code forces can also give me some answer. Sure, DP. Let's check all the links first. Cool. No right idea. Sure. अच्छा तो बेसिकली कुछ और सोचते हैं कि मेरे पास हर मतलब कि जैसे टारगेट में इफ़ वी हैव like let's say some bits on and some bits off, right? 11010110 something like that. So if a particular bit is on and if that bit is already present in the array, then we'll just take it and remove that bit, right? We don't need that again, like so. After all of this, we'll be left with some 0 bits, none of which have been fulfilled, right? And some 1 bits and some available bits, like we need to have 1 2 8 16 1 2 8 16 32 to be fulfilled, and we have these many things like 1 1 2 4 4 4 8 8 something like this, right? 16 16, right? Cool, right? So if we just start from the beginning, we will need to merge some available bits, so we'll need to merge some smaller bits, and also we will need to decrease some larger bits, right? So we can do this in this way only, right? Like if there is this seems to work fine actually. I think we can just try to merge bits and go on upwards and see whatever we can reach, like, because merging will never harm me, because let's say we need the 4th bit and we are just merging elements from the smaller ones, so the smaller ones are not required at all, so we can just merge them and get to 4 if we can get to 4, and if we are not able to get to 4, then that's okay, we are done. We need some backup, like from the previous bits, like from the greater bits, to break it, right? Yep. This logic seems fine. Cool. Let's just code it up. We have a time limit of 15 minutes only, pretty less time. These are the base cases which will be handled by the logic actually, but let's keep them only. So now of ll count of 31, right? For ll, for auto, and x in a, so I can do this in a much better way, but there is no time left now to think about all this. X and 1 1ll slash bit count of bit plus plus just a break, right? Okay, now this is okay. For well bit equal to 0, bit less than 31, bit plus plus, if t and l slash bit and count of bit, right? Count of bit minus minus t zor equal to l slash bit. Right, cool. Now we'll go from the smaller to larger bits. Sure. The smaller to larger bits. Smaller to larger bits. Right. Cool. For ll, bit equal to 0, bit less than 31, comma bit plus plus, right? If t and 1ll slash bit larger bits, continue merging from lower up till bit, from 0 to up till bit minus 1, right? For ll, bit 1 equal to 0, bit 1 less than bit, comma bit plus plus, right? And this count of bit will be obviously 0, because otherwise it will have been already be removed from this part. Let bit 1 equal to 0. Yep. Okay, count of bit. Okay, so like count of bit plus equal to count of bit 1 by 2, right? I think this is it. Like if there are 5 ones, then I can have to then I can get 2 2s from them, right? Cool. Now, yep. Okay, count of bit count of bit 1 plus 1 plus equal to count of bit 1 by 2. If count, okay, so after all these things, if count of bit, if we have now got count of bit, then well and good. Okay. Answer equal to 0, right? Answer equal to 0. Okay, so like we are not, so in the merging part we will actually not do anything, right? We will know this merging part is free of cost, like, yep. So that's how it is. So but if count of bit, okay, count of bit, then okay, then t zor, okay, so count of bit, then continue, otherwise you have to make it, right? Otherwise for ll, bit 1 equal to bit plus 1, bit 1 less than 31, comma bit plus plus. If ll next bit equal to bit, if count of bit 1 next bit equal to bit 1 break, right? Okay, now we just while next bit greater than bit, count of next bit, okay, minus count of next bit minus 1 plus equal to 2, right? Okay, so I just would be, and just have to answer plus plus here. I think this is a pretty cool approach, 3D approach, basically, which should work. Time left 10 minutes only. Count of next bit, okay, Okay, something is happening here. I think time limit exceeded. Cool. 1 to 87. Let's debug the first case first. Acha, got it. Next bit minus. I don't understand it. Now it is not. Okay, why now? Okay, this one is also bit 1 plus plus. Okay, got it. 1 to 87. Okay, so 1. Cool. The test cases run code. 1 0 minus 1. Okay, this one seems 0. Okay, why 0? See out answers lesson. Count of bit also will be minus, right? Debug it first. Answers lesson. This test case, right? Let's see. Right. Okay, answer is 0 because t, right? 132. Okay, so this should be okay. So let's see t here. See out t equal to t slash n. Okay, so t will not t will also not be present, right? T will be 12, right? Cool. Not bad. Now, so bit equals to 1. Count of bit 1 plus 1 equal to count of bit minus this should be done. 2. Okay, cool. Test cases, count of bit minus 1 2 minus 1 2 minus 1. This seems fine. Let's submit and hope that it works. Shit. 128 126. I don't know how this thing is working. Okay, if not 7 minutes left only. How 6 is coming here? So you have to bit equal to bit, answer equal to answer lesson. Bit equal to 1, answer equal to 0, bit equal to 1. Acha, why up till 4 only? T equal to 6, right? Bit equal to 1. Acha, cool. Bit equal to 1, bit equal to 2, right? So say out bit equal to, if the bit is 1, then I think it's doable, right? Equal to bit x equal to count of bit slash n, right? Bit equal to 1, x equal to 2, right? Count of bit, yep, 2, right? So for this case, yep, bit equal to 2, x equal to 1. How is it possible? Bit equal to 2, acha, count of bit plus count of bit plus 1. count of bit 1 slash equal to 2. This should be fine, I think. Okay, no, not fine again. Bit equal to 2, x equal to 1. T equal to 6, 2 to 0, 0, 1 is 2, 1 2 2 2, cool. Okay, so like 1 to 4, how it comes to be 4. No, this is wrong actually. How is it 2 actually coming? Count of bit 1 plus 1, right? Of bit 1. There's something wrong here. My approach is correct here, but I'm not have enough time left now. Till less time, but still trying to debug till the last moment. Count 4 0 0. Cool. Now what happened is that t equals to t analysis bit. Cool. Bit 1 equal to 0. Count of bit 1 plus 1 plus equal to count of bit 1 by 2. Cool. So I don't have to merge these things, right? This can be last time. bit 1 equal to 0, count equal to 2. Okay, now then bit 1 comes out to be 1. To bit 2. Not failed. How is it 2 actually? Okay, so it's actually 4 was remaining, right? So up till 4 we have added 2 here. Fuck. Just submit pro, not just submit pro here. Accepted in the last moment, yaar. Did I make it? I think I made it. I made it, bro. Oof. I made it in the final moment. Arey yaar. This is great. Okay, how many people solve 4 problem? Okay, not a lot. So I think I'll have a pretty good rank here. Oh, I solved in the last minute, and also I didn't remove the comments and all because I didn't have time. So there was a mistake here. Arey yaar. Pretty cool problem. I enjoyed this. but lot of summations also, or I think I am pretty bad at it. Fourth problem was much easier compared to the third problem for me. Yep, recording is on, right? So let's now discuss over the solutions to the problems. I think that will be pretty much fine. Okay, let's just check my final rank once. I think it will be somewhere. Okay, let's check once, like okay, I think it's okay, it will be around 180 190. I think it will be under 200 if this is fine, or it should be surely under 250. Okay, so I think that I can make the solutions in another video, because otherwise the video is already pretty much long, about 1 hour and 30 minutes, in which you can see me struggle a lot through the third and fourth problem, but that's cool. In the end we are able to solve all of these problems, so that's great, even after struggling a lot. Cool. Then I will make a separate video in which I will talk about the solutions for these four problems. The first two problems are pretty easy, but the third and fourth problem are good according to me. Maybe it's easy for other people, the third problem. Cool. Then have a happy weekend. Bye.